All right, this is Statistics, Section 1.2, Part 1. We're going to be talking about our Introduction to Statistics. That's Chapter 1. We're going to talk specifically about types of data. And this is kind of giving us a bird's eye view. So keep in mind that we're going to get down to some more brass tacks, a little more in-depth as we go along. But for today, it's going to be the bird's eye view of information. All right, so a major key concept. Use of statistics is to collect and use data to be able to draw conclusions about populations. And that's important in that it lets us know what kind of things we should be producing if you're in business, the likelihood that you're going to be successful in a certain field of employment. There's a whole bunch of other things that you can use statistics for. Those are a couple really simple ones off the top of my head. Okay, parameter. A parameter goes with the population. It's talking about some special characteristic related to that population. Now, I'm going to point out that this is one of those cases where we're going to have the same concept for statistics as we do for the for the population or the sample in the population, but we wind up having them have two different names so we can keep track of which one we're talking about. All right. So a parameter has to do with some characteristic of a population. The statistic has to do with the same characteristic of a sample. All right, so the way I remember it is statistic and sample, population, and parameter. If you have a better way to do that, you're welcome to use it, and certainly feel free to let me know. I'm always on the lookout for ways to improve. So here we have quantitative data, and it consists basically just of numbers. Okay, it's like things you can weigh, things you can measure, things that take up a certain volume. Those are things that you can just literally measure, and that's called a quantitative. And if you take a look, the root here is quantity, right? The root here is a quantity. There's also what's called categorical data. It used to be more often referred to as qualitative. So I want you to be aware that if you see the word qualitative, it's talking about categorical data. Okay, and this is categorical data is talking about a category, right? Having to do with a specific feature or certain attribute other than a measurement. Examples of that are including if you label something male or female when you're talking about professional athletes. So put the label on there as being male or female. Being able to tell which athlete it is by which team it is and the number that's on their shirt. That number on his shirt does not mean anything that's measured. It just is a number. It's a number that's assigned so that he or she can be spotted easily because the type for their names is very, very small. They want to be able to identify people quickly and easily. So that's why the shirt number becomes a qualitative. It talks about the quality of the thing that you're measuring. It tells you, okay, this is a person, this is this person on the field. All right, so working with quantitative data. Again, this is the one about quantity. This is the one where you're measuring. So quantitative data can be described in two different ways. So one is discrete, which means it's just that value, or there's no like fractions, and that's kind of a misnomer, but there's not a continuum. when we talk about ages, right, we normally talk in years old, right? Unless you've got a newborn, then it's, you know, however many weeks or days or whatever. But most of us do not wander around saying, I'm, you know, 37 years, 6 months, 14 days, 3 hours, and 17 seconds old. You know, we just don't do that. We normally will just say, I'm 37 years old. Or if you're closer to, you know, 38, you might say, I'm almost 38. Right? So you're putting it out there as a specific measure, but it's a discrete one. Okay? We're not counting out the continuum. We're just saying, okay, I'm in this year of my life. So that would be a discrete example. A continuous example, you can measure like how many points there are, how many answers there are on a number line. There's an infinite number of numbers on a number line. So we would say it's continuous, right? So in between 0 and 1, there's a 1/2, and in between that, there's a 1/4, and in between that, there's a 1/8. So you can just like keep breaking it down, and then there's all the irrational numbers that are in between there. So it winds up being quite the experience, kind of figuring out which one it is and then being able to use that information. They do give in the book, they give an example which seems kind of odd. They give you a mercury thermometer which allows the whole continuum of temperatures, and then they have the, you know, hold it to your forehead and zap, you know, to get your temperature. And those two things, one is discrete, the one where there's zap your forehead, and then the other is continuous because that's on a continuum. Okay? Hopefully that's making some sense. All right. So your discrete data, they're quantitative. The number is finite and it's countable. The number of tosses of a coin is an example of a discrete number of data, right? Another, the case of the continuous, you could have something, they're talking about distances from 0 to 12 centimeters. I use something more along the line of, sorry about that, more along the lines of, you know, an inch or 1 unit, but the idea is the same. You can keep cutting that in half and half and half, and there's no end to how small you can make that, right? You can make that everywhere along there. There's a point. All right, levels of measurement. This is a case where, and I kind of talked about this in the lesson. I want to make sure that we're real clear on it, though. There is this piece over here, right? And this is the qualitative. This is that, what do we call it? Categorical. Yep. The categorical method, or the categorical data. And let me just write that on there. Okay, so that's our categorical data. Yes, I realize my handwriting is terrible when I'm writing it sideways. Then we have what's called the nominal. Well, that's the nominal, right? Which is our categorical. And then we have this is ordinal. And then you have interval. and then you have ratio. All right, so here is a case where, and I'm going to see if I can't help make it clear as to what these, at least the three of them are: the ordinal, the interval, and the ratio. All right, so the ordinal is a case where we have measured something and then we put it into a category like grades, right? At our colleges, we do not say, 97.35. We say A, right? And so we know that there's this A, B, C, D, and F, right? So A, B, C, D, and F. So we know something about these. We know that this is considered being done very well. This is done not so well at all. So you've got this whole idea of kind of this ranking, but we don't know what each exact value, right? We don't know what these are for an exact value. We can say, A's are between 100 and 90, and then a B is 80 to 89.9, right? But that's a really big window, right? So in theory, you could have 20 percentage points there, or you could have almost no space, right? So it's really kind of, we don't know the exactness of it, perhaps. And actually, I'm going to stop at this point, and we'll do part 2 here in just a moment.